Today we're starting Unit 8 and we're learning how to solve polynomial functions. So solving polynomial functions uses all of our previous methods, all the methods we went over in Unit 7. If you look at my website or in your note packet that I passed out during class, there's a review section or there's 3 review sheets. If you want to take a moment and go over those, the answer keys are posted on my website, but those are all previous topics that we've learned throughout the year that will be useful for this unit and this lesson. So the first example set is just finding zeros of a function, and we've done this all year. So finding zeros is when you set each factor equal to 0 and you solve for x. So you can only set factors that have a variable equal to 0. If your factor does not have a variable, such as the letter x, then you do not set it equal to 0. If we look at number 1, we have y equals x minus 2 times x plus 1 times x plus 3. So we're going to start by setting x minus 2 equal to 0. If we set x minus 2 equal to 0 and we solve for that, we have x equals 2. There's one of your solutions. Next, we're going to set x plus 1 equal to 0. Solve for x equals negative 1. And lastly, we're going to set x plus 3 equal to 0. When we do that, we have a solution of x equals negative 3. So all solutions of this function listed from smallest to largest would be negative 3, negative 1, and negative 2. For number 2, we have y equals x times x minus 5 times x plus 3. We need to set each factor with a variable equal to 0. We're going to start with our variable of x. If we set x equal to 0, that's all we can do. That is our solution. X equals 0. Next, we can set x minus 5 equal to 0. If we set x minus 5 equal to 0, our solution would be x equals positive 5. And lastly, we will set x plus 3 equal to 0. X plus 3 equals 0 gives us a solution of x equals negative 3. If we list these numbers from smallest to largest, we will list them as x equals negative 3, 0, or 5. And for either of these problems, if you would like to check your answer, which is a good idea, you just substitute one of these numbers back into the original function and make sure that your solution is equal to 0. If you substitute it back in and your answer is 0, then you know your answer is correct. Okay, example set 2 is when we factor the polynomial and then we set each factor equal to 0. This is something we have also done this year. This should just be a review. To start with, you always check for a GCF. And taking out a GCF might be all you have to do, but definitely the first thing that you check for. Number 1 is f of x is equal to x squared plus 5x. So I'm going to set this function equal to 0, and I also recognize that there's a GCF of x, meaning I can factor out an x from each one of these factors. When I take out my GCF of x, left over is x plus 5. And once you get your expression to the fact of having all exponents as a value of 1, so right here, this is x to the power of 1, this is x to the power of 1. So once all of your exponents are to the power of 1 or linear, because linear is to the power of 1, Then you set each factor equal to 0. Our first factor, x equals 0. Our second factor, x plus 5 equals 0, giving us x equals negative 5. Our solutions are either negative 5 or 0. First you have to factor, then you have to set each factor equal to 0. Number 2, f of x is equal to x cubed plus 3x squared minus 28 times x. This also has a GCF of x, meaning I can factor out an x from each factor. When I take out an x, I'm left with x squared plus 3x minus 28. And then I can factor this expression, or at least try to factor it. So I need to think to myself, are there two factors that multiply to equal negative 28, that's a times c, and the same two factors that add to equal 3? And in this case, there would be. That would be 7 and negative 4. So I can rewrite this expression as x squared plus 7x minus 4x minus 28. I'm going to group the first two and the second two. GCF of the first group is x, left over x plus 7. GCF of the second group, don't forget that it matches that sign. So the GCF of the second group is negative 4, left over is x plus 7. You have your common factor of x plus 7, and you have your GCFs of x minus 4. Don't forget when you write this in factored form that you did take out a GCF, so we need to make sure that comes back into our solution. So 0 is equal to our GCF of x, our common factor of x plus 7, and our GCFs of x minus 4. At this point, you set every factor with a variable equal to 0. So the first factor, x equals 0. The second factor, x plus 7 equals 0, or x equals negative 7. And the third factor, x minus 4 equals 0, or x equals 4. In order, we have x equals negative 7, 0, or 4. And again, you can check your answer by substituting any of these solutions back into the original equation and making sure your solution is 0. Example set 3 is solving cubic equations. So this is when we did sum or difference of cubes in the last lesson. You want to use your sum or difference of cubes, which is then going to result in using the quadratic formula. Number 1 is f of x is equal to x cubed plus 64. So I'm going to rewrite this as 0 is equal to x cubed, and then 64, we can rewrite that as 4 cubed. And if you don't remember your perfect cubes, make a list down the side of your paper. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, and the list continues. So once we have this, we can see that this is going to be sum of cubes because we have an addition sign in the middle. We know that our a value is going to be x, and we know that our b value that we're substituting in is going to be 4. So just remember from the last time we did this that you don't need to include the sign with your b value because that's already figured into the sum or difference equation. So your a and b values should be positive and the signs follow through the equation. When I factor this, up here, I'm following the sum of cubes. So you're following this right here. All right, if we're following sum of cubes, this is going to factor to x plus 4 multiplied by x squared plus x times 4, or 4x. I'm sorry, that should be subtraction. And then plus b squared, which is 4 squared, or 16. All right, now we need to solve for this, so we set each factor equal to 0. This first factor of x plus 4, if we set that equal to 0, we can quickly identify that x is equal to -4. That one should be fast to find. But this expression here is going to be where you have to use the quadratic formula. You will have to do this for every sum or difference of cubes problem. And it doesn't necessarily have to say sum or difference of cubes, it just has to say factor. But factoring includes sum or difference of cubes, so you have to be able to recognize when you're using that. All right, to use the quadratic formula for x squared minus 4x plus 16, that means we're going to set up an equation, negative b, which is negative and then -4 for b, plus or minus the square root of b squared, -4 squared, minus 4 times a, which is 1, times c, which is 16. And this is all divided by 2 times your a value of 1. When I'm doing this, I always simplify underneath my square root sign first. X is equal to, right here, negative times -4 is +4, plus or minus the square root. -4 squared is going to be 16, and -4 times 1 times 16 is going to be -64. And this is divided by 2 times 1, or 2. X is equal to 4 plus or minus the square root of 16 minus 64, which is -48, divided by 2. And then off to the side, I'm going to simplify the square root of -48. Let's talk about how we've done that in the past. So first of all, you have a negative sign underneath that radical, which you can't have. So we've previously learned that when you have a negative sign underneath the radical, you can take out what we call the imaginary unit. So now we have I times the square root of 48. And if we can simplify the square root of 48, then we should. It is not a perfect square, but it does have a perfect square factor for simplifying, and that would be 16. It's 16 times 3. And then we can simplify the square root of 16. That would be 4. So 4 times I times the square root of 3 is our simplified square root of -48. All right, so I'm going to take this and I'm going to substitute it back into my expression. I have x equals 4 plus or minus. I'm now going to replace the square root of -48 with 4i times the square root of 3 divided by 2. At this point, I can simplify any number that goes into all terms. So all terms would be this term as a whole, and this term. Is there a number that goes into all three of those? Yes, there is. That number would be 2. 2 goes into itself once, 2 goes into 4 twice, 2 goes into 4 twice. So our answer is x equals 2 plus or minus 2i times the square root of 3. Now technically this is two separate answers. If I was to write out my two separate answers, I would write them out separately with this plus or minus sign. So one of my answers is 2 plus 2i square root of 3, and the other answer is 2 minus 2i square root of 3. Don't forget you also have your original answer of x equals -4. So if I was to list all of my answers, I'm going to list my whole number first. I have -4, and then I have 2 plus or minus 2i times the square root of 3. And this here is my complete answer. It's 3 separate solutions. Okay, next I'm going to look at number 2. Number 2 is f of x is equal to 8x cubed minus 125. So I need to rewrite that as perfect cubes. And I'm going to rewrite this as 0 equals 8 becomes 2 cubed times x cubed minus 125, which I'm going to write as 5 cubed. And then I'm going to take this expression and I'm going to use my exponent properties to rewrite this as, in parentheses, 2x cubed minus 5 cubed. My a value is 2x, my b value is 5. Remember, both of those numbers are positive, and this time we're going to be looking at the difference of cubes formula. So when I use the difference of cubes formula, I know that I have 2x minus 5 multiplied by 2x in parentheses squared plus a times b, which is 2x times 5, plus b squared, which is 5 squared, or 25. Simplify that to 2x minus 5 multiplied by 4x squared plus 10x plus 25. All right, we have to set each factor equal to 0. Remember that this first factor is going to be easy to set equal to 0. We have 2x minus 5 equals 0, or 2x is equal to 5. Divide both sides by 2, x equals 5 over 2. This solution will be easy enough to find. This solution will require the quadratic formula. And as I mentioned earlier in this video, if you don't remember the quadratic formula or anything else we're going over on this note sheet, check out the review section of your note packet or the website. I go over, or I teach the topics for quadratic formula, factoring, and solving by square roots. So using the quadratic formula tells us that we need to set up our expression as x equals negative 10 plus or minus the square root of 10 squared minus 4 times a, which is 4, times c, which is 25. This is divided by 2 times a, which is 4. Simplify this again. We have negative 10 plus or minus the square root of 100 minus 400 divided by 8. X equals negative 10 plus or minus the square root of negative 300 divided by 8. I can simplify the square root of negative 300. It does not simplify to a perfect square, but we do have some factors that we can use to write this in a simpler form. So the square root of negative 300 has a negative sign, so I'm going to start by taking out my imaginary number of I times the square root of 300. 300 is not a perfect square, but it has a square factor of 100. So I can rewrite this as I times the square root of 100 times 3. The square root of 100 is 10. 10I square root of 3. This is what I'm going to substitute back into my expression. So x equals negative 10 plus or minus 10I times the square root of 3 divided by 8. Check to see if any number goes into all 3 of these, and 2 goes into all of them. 2 goes into 8 4 times, into 10 5 times. When I write my final answer, I have x equals negative 5 plus or minus 5I square root of 3 divided by 4. And don't forget that you have your original solution, or the first solution you found, of 5 over 2. So I can list all of my solutions as x equals 5 over 2, comma, negative 5 plus or minus 5I square root of 3 divided by 4. And that's your final solution. Okay, and the last section of the notes is using quartic equations. So you have to factor and then find the zeros of the function. This might require you to use the square root property. Not on every problem, but on some of them, you're going to have to use the square root property. Also part of the review on the website and in the note packet. So when you're solving quartics, you factor the same way as when you're solving quadratics. You just have to pay attention to those exponents. So this first one, I'm going to rewrite this as 0 equals x to the fourth minus 10x squared plus 25. And I need to think to myself, what two factors multiply to positive 25 and the same two factors that add to equal negative 10? And your solution should be negative 5 and negative 5. So using the correct exponents, I'm going to rewrite this as x to the fourth minus 5x squared minus 5x squared plus 25. Again, those exponents are crucial. You cannot mess these up. When I group my first two and my last two terms, the GCF of the first group is x squared. Left over is x squared minus 5. GCF of the second group is negative 5. Left over is x squared minus 5. When I write these together, I have a factor of x squared minus 5 and another factor of x squared minus 5. So now I need to set these equal to 0. Let's start with this first factor. X squared minus 5 equals 0. Well, this is a squared term, so the only way to solve for this is to take square roots at this point. You cannot just add 5 to the other side and say that's your answer because you have x squared is equal to 5. So at this point, you take the square root, and remember that when you take the square root of both sides, you need to include your positive and negative answer. So in this case, x is equal to positive or negative 5. And that's your solution. Now this factor is identical, so you could solve that again if you want, but you're going to get the same answer. You do not need to write the same answer more than once, so if you end up with multiples of the same answer, I'm only checking for it one time. So I'm just going to circle this or highlight this as my answer. Again, we would get the same answer a second time, which I do not need to write. So x equals plus or minus the square root of 5. And for the last example, we have 0 equals 4x to the fourth minus 11x squared minus 3. A times c is 4 times negative 3, which is equal to negative 12. So I need the two factors that multiply to equal negative 12 and the same two factors that add to equal, it's actually negative 11. That's going to be negative 12 positive 1. I can rewrite my expression as 4x to the fourth minus 12x squared plus x squared minus 3. GCF of the first group is 4x squared. Left over is x squared minus 3. GCF of the second group is 1. Left over is x squared minus 3. When I write this in factored form, my common factor is x squared minus 3, and my GCFs are 4x squared plus 1. So you could try to factor this further, although it's not going to help you at all. So at this point, you're going to use the square root property. You're going to set each factor equal to 0, actually. So this first factor, x squared minus 3, set this equal to 0. X squared equals 3. Take the square root of both sides. X is equal to positive or negative square root of 3. For the second factor, we have 4x squared plus 1. 4x squared is equal to negative 1, and we need to isolate the x squared term, so we're going to divide both sides by 4. X squared is equal to negative 1/4. Take the square root of both sides. When you take the square root of a fraction, you're taking the square root of the numerator and the denominator. So this is going to be the square root of -1 divided by the square root of 4. Also, don't forget that plus or minus sign. The square root of -1 is I, and the square root of 4 is 2. So we end up with plus or minus I over 2. All of our solutions include positive or negative square root of 3 and positive or negative I over 2. All right, that's it for today's notes. Let me know if you have any questions and make sure to complete the Go Formative assignment.